Well, guys, thank you for another wonderful year of Plumbers. Thank you to all of you for making it possible, for coming here, participating, discussing, and having hallway conversations. We hope you enjoyed it this year. We had, a separate venue. And, hopefully there weren't, the food was good. The party will be even better. And so I just wanted to go through the usual summary. And for you guys, the micro-conference leaders, you are off the hook this year. We're not doing the readouts. Yoo-hoo! And instead of the readouts, you're getting a kernel panel. And so we're going to alternate. I'll do a little bit of a summary, and then Kate will run the kernel panel, and then I'll come back and give you some information. All right, so we want to thank our sponsors, obviously, because without them, we wouldn't be able to have a conference. So these are platinum sponsors: Facebook, Google, NetApp, Intel, and Huawei. And gold and silver: IBM, Microsoft, Metronome, and Collabora and ARM. The yummy food for breakfast and the breaks came from Dell and EMC. The microphones that hope maybe some of you received on your head this time came from VMware. Our media sponsor was LWN, they also hosted the website. We had a new website this year. Well, you will have a chance to give us feedback. And the T-shirt sponsor was OFA, Open Fabric Alliance. Okay, thank you. We also obviously are always in debt to the Linux Foundation for their organizational and logistics and, mostly patience with us. And Megan. And I don't see Trisha, but you probably know Trisha as well. So, thank you for putting up with us and our many iteration of revisiting the same decision over and over again in truly open source fashion. So what happened this year? We had 2 new tracks on top of the micro conferences. We had 12 catch boxes, 2 per room, 13 micro conferences, a total of over 100 hours of content between micro conferences, the new tracks, and referee talks. 209 different blocks of talks and topics. And this year we have a highest number of participants ever, 492 people registered, of which only 9 did not show up. So we have a really good participation ratio. So people don't register just to register. They register because they want to be here. So this is actually a very good feedback. Usually we are around 400 or a bit lower. So this year we tried to go a little above, but I think we have reached a limit as in terms of also interaction, hallway track and stuff. We're not going to go much higher than this, because I think this is good for a productive conference. And if you expand much more, then you lose the advantage of finding people and having time to talk to people. And obviously, the number of beers that was consumed on Tuesday night, that's also staggering. All right, so I was talking about the new tracks. So one track is David Miller and Daniel Borkman that ran the networking track as part of Plumbers. So that went well. Special thanks to both of them for working with us. And then thanks to Ted for organizing the Kernel Summit together with Plumbers this year. So an applause for Ted as well. Where is it? And of course, the people responsible for this year, so we take praise or complaints. So it's me, I'm the chair this year, and then Laura, Kate, James, John, Jake, Guy, Steve, Yes, and David. So feel free to reach out with comments and so on. So right now, we'll pass it over to Kate for the new edition of the Kernel panel.
Thank you. Let's see if this microphone's good. Okay. Well, I'd like to invite our Kernel panelists to come up to the stage and join me up here. And looks like we've all got microphones. Excellent. So what we'd like to do this time around is try to keep this a bit informal and be able to ask questions back and forth. But I'll start off with some questions, and we can go from there. So let's just start off with some introductions. So Shuah, do you want to start us off, and we'll just go from there? Yep. Introduce yourself and what you work on.
Yes, my name is Shuah Khan. I am a maintainer and contributor. I love doing what I do. It's awesome.
I'm Anna Gleixner, and I'm working for Linux, and there I'm working in the team who's trying to, or is working on bringing RT patch set mainline.
I'm Laura Abbott. I'm one of the Fedora kernel maintainers.
I'm Anna Schumaker. I'm one of the NFS client maintainers.
Julia Lawall. I work on Coccinelle.
Welcome. Thank you very much. So one of the first questions is, when did you guys each submit your first patch to the kernel? Julia, you want to start?
Okay, so that's a funny question. So I was looking for the answer last night, and it was exactly 11 years and 1 day ago, November 14th, 2007.
I think I would have been summer 2010-ish. So.
Okay.
Probably sometime 2010, 2011 that I actually got something upstream.
2012, but then there was long time nothing, and I also thought that this would be the first and only patch set I submit.
For me, I think it's late 2011 or early 2012. I actually removed something from the kernel as a part of Android mainlining effort.
Okay. And so, why did you do it, and what was the experience like?
For me, it's been very positive. So I worked with Android mainlining team, figuring out what I should do, and then I talked to, I think Tim Bird, was doing the work, and then I contacted him and I said, hey, I want to help you guys, and he gave me a lot of pointers on how to figure out what I should be doing, and then I volunteered to do some things and started working on that. So it's been very positive experience for me.
Yeah. And then my first patch I started working on was something I found internally after spending far too long trying to figure out a division by zero error, because it turned out on ARM at the time we couldn't actually get a full backtrace to see where the division by zero was occurring. So I had to do some digging to add some annotations to add that, and I submitted the patch upstream, and I got some feedback and saying, hey, this looks great and useful, let's make a little bit tweak. So I submitted it and I got it accepted, and it was honestly really exciting to get some useful feedback to be able to correct it and actually get it in and know that in the future you'll actually be able to see where your division by zero error is actually coming from.
Do you have any stories with yours, Anna? What motivated the first
So I think
one?
it was right after I started at NetApp. I was working pretty closely with Trond Mikkelbust, the other client maintainer, so he just gave me something easy to work on, and that turned into my first patch.
Okay, so we started developing Coccinelle a few years before 2007, maybe 2004, 2005. And so we thought it was a fun tool to use, and it seemed like it was doing something useful. And at the time, I had a postdoc, and so I would make the patches, but then it was kind of a nuisance to actually send them out, because at the time you had to go through the maintainer's file and try to figure out, this is USB/XYZ or something like that, so where does that fit into the maintainer's file? So that was kind of a nuisance. So I had my postdoc and he sent them out. But then he moved on to better things, and so I wanted to continue interacting with the Linux kernel, so then it kind of fell onto me to do that. So.
Okay. So one of the things is we've had a really busy week here this week, by far. There's been a lot of parallel tracks. Can you guys, since we're not having a readout, can you guys tell me which tracks you found really useful and interesting, and if there's any specific things you want to highlight for people to watch in the videos or things like that? Okay, Shuah, go start.
Okay. So this is the first time in some conferences I haven't actually spoken. So, but I had a lot of fun floating from track to track. Networking track is awesome. I learned some things that I haven't been, with the kernel being so large, it's always difficult to keep an eye on everything, so right? I mean, what's happening. So one track I attended was, one of the talks I attended was UDP optimization. That was good. And then eBPF, a few of those talks I attended. And then the other one I attended is Kernel Summit, some of the Kernel Summit tracks, of course. I found especially the Code of Conduct and Maintainer Handbook talk, Dan Williams. I'm glad he's doing that, and it's just awesome. So thank you. And those are the ones I paid a lot more attention to.
How about for you, Anna Maria? I think I can guess which one was probably the most fascinating for you, but please go.
I used this conference to see what's going on, and I'm not working that long with the kernel, so I do not have a lot of deep technical knowledge, and so yeah, I hopped around, and the only track I was followed from the beginning to the end was the RT track, which was quite fun, and yeah, there were also some interesting discussions and some results for future work.
I bounced around a lot. I spent a lot of time in the hallway track, a lot of time the refereed track, a couple of refereed topics that stuck out. The discussion about WireGuard, from both the actual WireGuard API to the stuff on the crypto side. That was really interesting to see. Excited to see progress in that moving forward. Let's see. The discussion today about moving to GitLab, that was also good to see, pointed out perhaps maybe getting more people open to things that are not just email and exactly the trade-offs involved in that. And then for microconferences, I spent some time in the Android microconference, and when I first started in the kernel, it was in fact on Android, so that's certainly come a long way. It's fantastic to see everyone continuing to really work and be dedicated to making Android work with upstream and be a good participant in the upstream community.
I mostly hung out in the Kernel Summit track, and I agree that the Code of Conduct and Maintainer Handbook talks were really cool. I also like seeing just the number of talks that were like college PhD research projects. I thought that was really interesting to learn about and know that PhD people are working on the kernel.
So in general, I'm sort of interested in things that have to do with code and verifiability and showing the consistency of things and so on. So I was most interested in the testing and fuzzing. It was kind of obvious, finding bugs and so on. The RT track is always interesting to me because they're working on getting the RT patch in, so there's a lot of low-level code sort of issues. And also device tree is another place where people are interested in showing things are consistent and correct and so on. So
lots of work and reports to do there, definitely. One of the areas is we've got a lot of interesting challenges ahead of us right now in the Linux kernel in many areas. And we're seeing more and more with the Linux kernel going towards safety and safety-critical applications. And so as we move in that direction, That's one of the ones I'm seeing, but there's other ones there too. So I'm just sort of wondering, what are the biggest gaps we've got right now in your mind, and what are the areas we need in the kernel we need to be addressing?
Testing.
What?
Testing.
Testing, okay.
It's mostly, it's great to see that the kernel is finally coming around to making sure we're having a lot of automated tested. I know we've heard for years that many eyes make shallow bugs, and that's the great way to find bug, which is absolutely true. I think we can continue doing our code review, but we can supplement that as well with automated testing just to make sure that we can catch the things that humans don't. And one of the things, at least I'm going to be thinking about and looking at, is seeing about how to make sure container testing works. So I'm a distro maintainer, so what I'm looking at is a lot of times what users are using, and one of those things these days is containers. So my goal is to never get someone who says, hey, Docker doesn't work, so.
Anyone else want to go?
So it seems like what's important in this area is the development of processes for showing that you have what you think you have and so on. So what's interesting is, I mean, today there's a number of static analysis tools that are available, and there's a certain amount of overlap between them, and it's good to have some kind of tools for bringing all this together and trying to understand exactly what we can say and what we can't say, and what we have found and we haven't found, and so on.
Go ahead, Shuah.
So yeah, definitely testing. I'm finding that Sysbot effort has been useful, immensely useful. I have been fixing several problems in the driver I maintain, finding problems there, and then there is K-unit efforts happening with the. So we are making a lot of progress in testing space, definitely. So I was just looking at K-self-test and see how far we have come in the last 4 years. It's a 3 times improvement in terms of the subsystems we are covering now. When 3.17, in 2014, we had like about 15 subdirectories. Each subdirectory is a target subsystem. Now we are up to 46 or 45, last time I counted. I haven't checked again after 4.20, but 4.20. But yeah, we've made, it's not just in the breadth, it's depth as well. Networking, each subsystem has added so many more tests. So it's a tremendous growth. And we're also seeing that K-self-test is being run in narrow test forms and in several test strings. So it's being used in stable releases. I'm happy to see that.
So as we're looking towards the safety issues and so forth, obviously getting everything upstream is going to be key. I'm just wondering, Anna Maria, can you talk a little bit about what's going on with the preempt RT stuff going upstream? Sure. And some of the implications on future device drivers? And some of the implications for future device drivers are going to have to deal with real time being there?
Generally, when real time will be upstream, there will be, or it will not behave somehow different than when another feature will come upstream, because if you do something which will break the feature which was there before your change, you have to fix it. For example, one big thing which is problematically for RT is preempt disable sections, for example. So yeah, there we also need better test coverage, because we will not be able to test all the drivers around if they will be compatible with RT. Yeah, so testing is one thing, and make sure you do not use preempt disable sections.
Mm-hmm. Anna, do you have any thoughts in this area, or?
Haven't really done much real time.
Yep. Okay. Or in the whole as big. What are the gaps you see?
Definitely need more tests. So just keep contributing to XFS tests. I run it all the time. The file system fuzzers have been great. So
okay.
Been having fun playing around with those for system call verification and stuff.
Okay, I'm getting the theme. Okay, testing is going to be key. We need more tests. And we're going to have to keep working on getting our test infrastructure built up so we can keep the quality up as we get more and more complexity keeping going in. Okay, Shuah, what's the roadmap for K-self-test looking like?
So Driver tests, we are a bit weak on that, so I'm looking for more contributions there, definitely. And then another area we are a bit weak is architecture, I think. PowerPC and x86 are great, in great shape, and we have a lot more tests coming in, but we are a little bit weak on ARM and ARM64. So I have been talking about that at various conferences and saying, hey, we need more tests in that space. So that will be definitely great. And drivers, driver tests and being able to, that's a tricky part, right? Because sometimes you need hardware and sometimes, but if we can add some way of doing those tests, that's great.
Okay. Anna Maria, what about, are we going to be needing some change? Do you have any comments on the comments on any changes we're going to be needing for testing real time? And are we going to be needing to see some infrastructure there for performance too?
Yeah, during the development of real time, we already have a test set up, but it's quite small. It's Jenkins based, and it will, one important thing is that we find a way so that we can also see if there's a difference in latency, for example, if some core components change, if we can see increasing latency between different kernel versions, and so then find a way to find the cause for this. So, but there need to be done a lot more than we have right now.
I think we're all getting that theme. Anna, do you have any thoughts about the whole testing roadmaps and what needs to be added?
Nothing more than what I've already
said.
said.
Yeah, I know, okay. I figure. Laura, what about from a distro perspective, and getting things ready to ship?
Yeah, I think definitely figuring out what more testing we're to look at there. I mentioned containers, but also just on a daily basis, trying to figure out what are the things that distro users tend to break or see broken. A lot of the times this is things like graphics drivers or input, so making sure those work. And also third-party modules. One time I accidentally introduced a packaging train, which meant you couldn't actually build third-party modules. So adding things like a test to make sure you can build those and everything there. So yeah.
Okay, Julia, what's next for Coccinelle?
So for Coccinelle itself is kind of stays the same. So we planning to add, we hope to add some new features. I'm thinking of like annotations, so like init or exit, things like that, so you can reason about them, maybe if-defs, so you can reason about them, just to be able to express a bit more. We're more developing different tools around it in different directions. One thing we would like to do is help you infer Coccinelle specifications so you don't have to write them all by yourself. So the idea is that you can write some examples. So there's kind of a typical use case, which is that you start making some big change, or some change, you do 10 of them. You say, oh, I remember that Coccinelle thing, I should have done that instead because there's 70 more I have to do. But, it's been like 6 months since I last looked at it. I don't really feel like looking at the manual. I'm kind of lazy, so I'll just plunge through these 60 more changes, maybe make a few mistakes along the way. So the idea is that you make your 10 changes and then you give it to our tool. It's called Spinfer, and then it will infer a semantic patch for you, and then you can go off and make these 60 other. I don't know why I hear people laughing. So hopefully that will happen. It works a little bit now. So maybe it will never work perfectly because some things you want to do are actually fairly complicated, but maybe it'll kind of give you a hint and then you can go further by yourself. So that's one thing we're interested in. Another thing we're interested in is issues around backporting. Helping you find information, helping you detect problems that will affect your backport or your forward port or whatever port you want to do. So part of that, we have a language that lets you write specifications that are sort of like Coccinelle's change specifications, but allow you to search for changes in the past. And so that will help you find examples of changes that other people have made, which are sort of like the change that you want to make. So that's another direction. So we're kind of using the infrastructure of Coccinelle to think about other kinds of development problems.
Very cool. And as we think about lots of development problems, we've obviously seen lots of very interesting hardware vulnerabilities as well as software vulnerabilities over the last year that have come into our kernel. You know, in addition to the ones that are getting resolved in the software and firmware, but do we think we're going to be needing to see some changes in our processes on how embargoes are handled based on the type of vulnerabilities? Are we going to need to look at changing our processes as we move forward? Do you guys have any opinions and thoughts on that?
So one of the areas that I had to do a lot of fixing is one of the drivers I maintain, and there would have been lots of security problems that showed up. My takeaway from fixing all of those, plus combing for more and fixing them, is that this driver has moved from staging to mainline, and maybe during that process we could have probably made it's hindsight is 2020. So, but maybe some of the things I have been giving one talk, sharing my tips and such, going sometimes it's easier to think about certain things when we are writing drivers, in terms of, especially when the drivers have lots of drivers act on data that user space sends, which happens to be a USB or IP driver. So it's a vector, security, huge vector. So thinking about what could go wrong at the time of coding would be helpful. So that's what I learned. Yeah, that's one of the things. And then, just looking out for possible security issues during coding reviews, and then also looking for them and introducing tests that would avoid. And some of the reproducers, they come in with the CVEs. I have been looking at those and seeing if I could put them into kernel self-test and add them to it so that we can do continuous regression on those.
Don't get the regressions, right. Does anyone else have any thoughts about how do we deal with the different types of hardware bugs as well as the software bugs we're starting to see, and the embargoes?
Embargoes are a touchy subject. They do serve an important purpose, mostly for coordination, but at the same time, it can sometimes end up being can be dragged out too long. I work on the security team, the security at kernel.org, and help with there. And I think generally the preference is to try and do as much as we can in the open. And I think that's one of the biggest things I've heard from talking to everyone involved about the Spectre and Meltdown stuff is that not being able to develop anything in the open was a big problem. As a distro maintainer, because the way I came in, I actually found out about Spectre and Meltdown I wouldn't necessarily, later than some people, but certainly not as late as other people, kind of a midway. So, but most of my job also works on mostly the upstream kernel, so I was able to just take whatever patches were being developed in the open. But again, it was still kind of a pain to have to figure out who knew what or who didn't know what. And so continuing to figure out how to adapt our processes because when the next hardware vulnerability comes. And I also like the message that a lot of people have been spreading about getting to really know the hardware and interact more with the hardware architecture teams, which is another, I think, in the spirit of plumbers and really getting together and solving problems, getting together with hardware teams and solving problems as well.
Yeah, we actually had the RISC-V community here for the first time this year. And so welcome to them. And I thought there were some interesting discussions going on with them. And that's going to be a whole new set of problems, I think, for us as they emerge. Anyone else have any comments in this area? Or nope, okay, that's cool. I don't want to completely leave the topic of hardware vulnerabilities, though, and security vulnerabilities. So one of the things I'm wondering is, do we have the right tools in place today to be effective at supporting kernels for these long-term periods? As we're getting into more fields where kernels are deployed in applications and remote, and they want to be running for 6 years, like the smart cities, things like that. What sorts of tooling do you think might be needed here if we don't have it? And is there anything that you guys are thinking about in this direction?
So I just wanted to make one comment with respect to what Shuah said.
Yeah.
That, it's like somehow all the code just looks like code, but some of it's not exactly just ordinary code. Some of it comes maybe from user space or something like that. And somehow that information, I mean, you can see like a get user or something like that, but then the influences of that kind of get lost as you drift around in the kernel. So maybe there could be some kind of benefit for maybe more annotations or more tools for propagating this information or highlighting how data flows around in the kernel, so that one could understand better what's sensitive and what's affected by different hardware issues and so on. It could be something to go forward in the future.
Yeah, that's part of it. When I was looking at different packets that flow into this particular driver, and what could be the vulnerabilities, like for example, what happens if this particular field, malicious packets coming into malicious intent packets to panic the kernel or have the kernel go off the beats. Those are the data flow, like data flow from user space into kernel space. So that would be useful, definitely.
I guess as you think about the long term, having seen a lot of different ways to maintain kernels, both good and bad, I think the biggest thing you end up needing is for any tree is knowledge about what is actually in the tree is a good starting point. You can't actually figure out if a hardware or software vulnerability applies if you don't know what's in the tree. So I think tools that'll build off of that help you figure out if a patch needs to apply. I know Julie's done a lot of work with machine learning to try and figure out if stable patches apply. I know that's an example of a pretty simple patch, but maybe something like that down the line is a good way to supplement about what maintainers already know and try to figure out how things go in the long term.
Yeah, that's definitely, I did attend that talk, and then it's awesome because it's if you're seeing auto-select. But I mean, it's a cool way to be able to. If I as a maintainer, I don't always think about CCing stable, or it just slips my mind, and I go, oh, I didn't tag it. So it is a cool tool to be able. It's a great application to be able to do that. And then another tool that I found very useful for debugging is Cregit. I'm using it for debugging. So.
Thank you.
I had to mention that.
Tool, so.
No, it's not Kate's tool, it's Daniel German's tool, but I'm just a big
I'm using it for
debugging.
I was just going to second the machine learning stuff that they've been working on. So fingers crossed that people at least update their kernels when they're running long-term support stuff.
Right.
Okay. So turning things around a little bit, what do you guys think has been the biggest missed opportunity to improve the quality of the kernel over the last few years?
For me was a big problem when I started. I think it was some hop plug rework stuff, which was spread all over the tree. One main problem was that I rely on documentation. Or I relied on documentation and get several times confused, like, doesn't make sense to me because there's something else in the comment than in the code. Or the other problem was missing documentation. And this was one thing I was really missing at the beginning, and also missing sometimes right now. But I also know, even if I develop some things, that it's hard to write documentation. So I don't know if there's a way to find someone who's maybe more able to write documentation than the person who developed it. I don't know, but this was one thing which is sometimes hard and was hard at the beginning.
Anyone else have any thoughts on the missed opportunities?
I think also just figuring out how to continue to get more people involved. I gave a talk last week about intermediate ideas for getting involved at the intermediate level in the kernel, which is kind of a big gap. I think there's a lot of discussion about here's how you do your first check patch or your first fix a warning, but then what are ideas to get more substantially involved, and figuring out how to maybe get newer people, or either people who are just super enthusiastic and really want to be in the kernel, which are the people we want to encourage.
So hopefully the code of conduct stuff will at least make us seem more approachable, so people will submit more patches. And
Okay. So what technologies are being added that you're excited about then? Not just the gas. What makes you like, ooh, this is so cool? We've heard of a few of them already, actually, but anyone else, anything else you want to add?
So one thing I was talking in the hallway with the PCI maintainer, he's really excited about the PCI peer-to-peer DMA, and I'm excited as well because I worked on PCI before, and then I thought that's a great way to be able to, two devices, to be able to exchange data without involving. So I thought that would increase performance quite a bit. So I'm personally happy to see that.
That one going? Cool.
so one thing we're working on in NFS land is extending the VFS copy file range system call so that you can copy between super blocks of the same file system. So NFS 4.2 has this copy operation. You can copy between servers in a single hop just by having one server read the data from the other one. So it's much faster than reading everything over the network and then writing it back. So we're gradually working on improving the system call and adding support for this.
I guess the last sort of topic I'd like to sort of cover in this area and then probably open up for questions is we're hearing a lot about the gap in maintainers and how do we actually start to get more maintainers into the system. And you know, is our email-based processes still working for communication and interacting? These are all sort of not quite directly together, but they are sort of part of the flow of our process and how we actually work. Do we need to look at, does it feel it's working for you, or do we have, like I say, we had the session about creating a maintainer handbook to help try to bring in maintainers. Are there other steps you think we should be looking at for making things more approachable?
So maintainer handbook definitely helps, at least communicating maintainers and how we work. Sometimes we don't always make that very clear, unfortunately. And then as I think Dan was mentioning, and I share, we tend to straddle both contributor. When we are a contributor, we are like, okay, what is happening with my patch? But when you on the other side, when I'm maintaining something, I might go a week not responding to a patch, and all of a sudden go, oh, I'm sorry, I seem to be doing that. So sorry, I didn't respond sooner. So I think it does help to at least have document expectations.
Yeah.
And then that at least help the contributors. And then the other thing I have been thinking about is for my subsystem, I do rely on some reviewers doing reviews, and then and there is some subsystems do this. They have a reviewer in their maintainer file, and they rely on those reviewers, and those reviewers are kind of second in line if maintainer has to take time off or vacation, you know, disappear into the woods for a bit. So I think that's a good thing. I haven't done it for my subsystems, I should say, but you know that would be another way to kind of, you know, get that going. Yeah.
Other Anna or Laura?
The topic of email and maintainers is kind of an interesting one because I think ultimately what it kind of is that it's maybe a bit of a learning curve. I'd say is that you can certainly learn how to work with email and you can be effective at it, as everyone has shown. But the question is it necessarily the best way, or as we think about trying to get new maintainers? And I mean, it can be intimidating, and I'd say that the email workflow actually works best for maintainers just versus as a contributor. I think there is a lot of advantages to other flows, like say GitLab model for more contributors. As far as maintainers goes, I'd like to believe is that maybe we can start to think about other ways to try and move forward, just because setting up email is in fact still a pain.
Yeah, so we're definitely still email-based in NFS. I think there's just a lot of momentum there. So I'm open to trying GitLab and any of these other things, but we'll see if it's better and if everybody switches over. But if everyone stays on email, it'll be hard to move.
Okay, cool. Well, I guess with that, does anyone have any questions that they want to be asking? We'll basically bring a microphone up. Any questions for the panel? Okay.
So I'll give you an observation and a question. So on this panel, my observation is that you each have a lot of diverse experience bringing new people into the kernel. So, and thank you very much for doing that. One of the things I would like to ask is, based on all of this experience, if you could change one thing at Linux Plumbers Conference to make it more accessible to new people, what would that be? And of course, thank you for the ideas, because I'll be taking credit for them.
First idea is that James Bottomley personally comes and introduces himself to every new person. I second that idea. More seriously, we kind of threw out the idea about, I think there are a lot of us here who attend who are happy to try and talk to new people. So figuring out if there's a way to put a marker or something that says, hey, you know, I'm a maintainer, I've been around here before, come talk to me about stuff. I'm excited to talk to you.
So the green stickers aren't enough.
The green stickers, I think, are kind of a subtle, different, that's more general communication. This is more, I'm enthusiastic and I really want to talk to you, so.
More green stickers.
So for me, I think green stickers are working. I mean, you know, a lot of people came up to talk to me, and then, you know, I think that the hallway track has been awesome in this conference, I have to say. I spent a lot more time outside in hallway than in the rooms, so, you know, it's great.
Any other questions? Oops, just here a second. So I'll just... I didn't think to bring the catch boxes here. Sorry, guys.
Have you any thoughts on the fact that we always try and fix things, for example, the email thing, but being someone who's quite new, like, I'm attracted to the kernel because of some of these Luddite systems. Like, but there's never any discussion that, oh, maybe these things aren't broken just because kids like using web pages. You know, some people are still attracted because we don't use them.
Sure.
So I think if I heard the question right, what attracts us to the kernel? Is that the question, or I don't think I'm sorry.
What's working quite right?
Yeah, there doesn't seem ever to be any discussion on like we don't have to change everything. So I was just wondering if you have any ideas on how we know when things are working, because some of us are attracted to it because it's like it is, and so we've been attracted and now everyone wants to change it.
So I think what I like about the whole process is, I know there is a debate about emails versus GitLab, and I mean, I think I'm sorry, I'm drawing a blank here.
There's over 60,000 files in the kernel right now. There's a tremendous number of subsystems there. There's a wonderful diversity of opinions we can mine to figure out how to make things better. And each of them is, in some ways, is its own little culture. And cross-pollinating these ideas, it's working it's working right now, no question. But being open to new ideas to coming in and being open to new ways of doing it is going to keep the kernel vital going forward. And so that's kind of where my head's at. And that's part of why I study the kernel's archaeology.
So that's kind of what we keep doing, right?
Yeah.
So far we have been doing that, you know, continuously evolving and then improving and bringing new ideas in. And then we are also moving towards more and more. We have a diverse community as such of ideas, and then also looking at the number of us up here, we're also improving in that area as well, having diverse ideas and thoughts, people and thought process and such. So I think we have to continue to do what we are doing and then keep making progress in terms of attracting more and more new people. And one thing, so that's continue to do, maybe mentor more and doing mentoring and helping newcomers come in and share our experiences.
So there's been, in the last, I think, 24 hours, like an initiative to document some really small details about different subsystems, and I think that's a really helpful thing because I think many people can get frustrated if they try to contribute to something and then the maintainer says, no, I like all capital letters, I don't want lowercase letters or something like that. And so then the contributor feels like, you know, why didn't you just tell me this up front? Why do I have to have this round-trip interaction of email with someone just to find out you want all capital letters? So I think if people have specific preferences, if different subsystems have specific preferences, then making those preferences more clear, apparent once and for all, can help a lot to make people not feel frustrated about their interaction with the kernel.
Real quick, this is actually Anna Maria. You brought up documentation that you stated maybe it's not always the best that the person who wrote the code documents it. How, anyone can answer this, I guess, would be for that, to answer that question, who should be documenting? How do we go about doing that? I mean, ideas.
I also have no answer to this question, but no, sometimes if I would have to document something which is totally clear to me, maybe then I would miss to explain some points which are not clear to a person who is new or who has to understand more than I, because some things are obvious for the person who developed this. And this is one thing this is one part of the missing documentation, that if you read documentation to try to understand something, you get like stuck because it's like a level too high or too deep, or there's some point missing where also new developer can start. And this is, I think this is complicated to decide where you have to, how far you have to make the documentation, but I also do not have an answer who could write documentation.
So I think in part maybe the code should be the documentation, and it can be helpful to have tools or something to help people find their way around the code and find the relevant, whatever concern they have at the moment, find the code that's relevant or find the patches that are relevant. One thing that's very nice about the kernel community is people are forced to write good commit messages. And so if you can find the commit that makes a change that's relevant to the thing that you're interested in, then maybe you can find an explanation about why things are the way they are.
But
so
I think
it's not just, I mean, a document is good, but as you say, the person who writes the document doesn't always have the same perspective that you have. And so sometimes you can get this information you need from other sources.
Yeah.
Or you can come to this conference and you can just talk to the person who's relevant, and then you can find out the information you need much more quickly.
Hopefully reviewers will at least be asking questions if they're not in your head, even if they know the subsystem. So people reviewing patches on mailing list or GitHub or whatever should at least be asking questions if documentation isn't clear to them.
this is right, but one thing, this git blame stuff to find the commit message is a very wonderful thing, but maybe this should be also like think about you're working with Git for newbies, because for me it wasn't the first obvious thing I did to use git blame. Maybe it's because I never worked before with Git, so it was like, yeah, good information for newbies. Use git blame, commit message are mostly useful.
Okay.
Anna Maria, I wanted to ask you about something you said earlier. You said that you hated having out-of-date documentation and no documentation. For you, which is worse? It's actually quite a serious question.
Out-of-date versus none.
Yeah.
Missing or out-of-date documentation, which is worse?
Yeah.
Out-of-date, because then I get more confused.
That says to me that if we can't commit to maintaining a document, we actually shouldn't document code at all, which is something. No, that's actually giving me something to think about, because we put in these efforts to get things documented and up to date, but the lesson to us is if we don't maintain them, we shouldn't have bothered. So we are giving ourselves a puppy, and we have to keep looking after it.
I don't think it's we shouldn't have bothered. I think it's more just we have to realize is that what's the purpose of documentation, and that sometimes it's going to be explanation of the design decision at the time. Sometimes it ends up needing to be a reference about how to actually do something, and both of these things may need to be updated at various times. So I know you're not trying to say to get rid of all documentation, but I just want to make clear we shouldn't get rid of all documentation.
No, but one thing is maybe when reviewing patches or when changing things, that the person which are reviewing also have an eye on is documentation also like on my checklist when I review a patch, I should have a box for did you check the documentation is fine with this, with the change.
So one of the things with the Kernel project is that it's been one of the fastest moving projects. I don't know if it still is.
It is. It's still the fastest moving. It's got the highest velocity project by far.
So we've been able to keep it up. But what do you see being the bottleneck for getting it up to 10x the speed we're doing today? What do you think we need to fix to sort of unleash and move even faster?
I think it's just, I don't know if as maintainers we can keep up. You know, that's one thing I kind of think about sometimes. I mean, we're catching up, playing catch up constantly. So, number of maintainers, I guess. Because there is lots of subsystems and lots of patches coming in constantly. And so I don't know what's the solution for that, but at least that's kind of what I see as one of the issues.
I mean, it's sort of a problem because the code gets bigger, and when the code gets bigger, then it gets harder to move forward if there's more things you have to change. And there's a comment the other day in, I think, the device tree workshop, like, we would like to do a certain thing, but, you know, it's going to be really a lot of work, so maybe we shouldn't do that thing. So that's something that slows things down. So we need tools to get our hands on the code in the right way so that we can move forward faster.
Okay. Oops.
Here. So
There's one more question over here, and then we'll bring it over there.
February 9th, 1999, Linus Torvalds came to HP Labs and talked, and one of the comments he made there when we asked him what should we be doing at HP to support Linux was, please provide documentation for your hardware. So it's good to see that Linux now is part of the problem of brought in documentation. That's the first part of it. The second part of it is that the documentation is, in fact, really is still a problem, and reading the code isn't always helpful. Reading the comments, even the commit messages, isn't always helpful. What I'm finding is that very often the commit messages that we get from people, and because I maintain the distro, I'm working for Chrome OS, and I maintain the distro there, and I see commit messages from partners, which are, you know, fix as hang, and that's it, right? It doesn't tell you anything about it. So the commit messages are mediocre at explaining things, I think, in general, even the better ones. What I'd really like to see is more comments in the code itself that explain things, or annotations even in the code that explain why things happen. You know, the why part of it is very hard, and I think that's up to maintainers to sort of establish that they need that and they want that. The device tree maintainers have done a really good job of trying to force, every time you add a binding or something to it, where is the documentation for this binding? They won't accept it unless they include it. So maybe the code of handbook for maintainers would help set that expectation that you require a certain amount of documentation with your changes. Having said that, the DMA API, for example, has good documentation and has survived for a very long time already. It's been around, it hasn't changed very much, and it's been very helpful, I think, for people. So there's examples of documentation that have been very useful. Greg Hartman's book, The Linux Device Drivers, version 3, which should have been version 6 by now, I think, but nobody's written or updated that either. That would be a good place to also sort of update the documentation. So somebody, maybe we can get Greg to do another version.
You can ask him that on another panel.
There's no question unless you guys have more to add to that.
No, sounds like you answered your own question. So.
And I'm sure Greg will be on a panel at some point in time again, and you can ask him definitely there. What?
Anna Marie's observations are
excellent. He was just complimenting. He thought your observation was excellent. Thank you.
Thanks.
Okay. There's some over there, and I'll come back. Oh, we're running out too? Okay. One more question. Sorry, guys.
So we've been through this before. I remember everyone saying, Linux doesn't scale. What are we gonna do? What are we gonna do? Linux doesn't scale. And at the time, what saved us? A piece of technology, right? It was BitKeeper to teach us about how to use, version control. Yeah, at some point we didn't use version control, by the way. And then Git to really hone in the point to have something to make maintainers and Linux at the top scale in some way. So that solved the problem in one dimension for maintainers, and right now we're hitting a wall again, all of us, right? What do you think is that other dimension that technology needs to step in to help us scale as maintainers again? That's really what I want to know.
Back to the tooling.
I do think there's a lot to be said for automation, and mostly to get rid of a lot of the annoying repetitive tasks. The point is that if you have to find yourself doing stuff a lot, don't try and do that, and mostly make it easier to see exactly what you need to do. Maybe can we figure out how to get tools that will make it easy to see what's been reviewed, what needs to be reviewed, what's in the queue, what are people actually saying, maybe what are the hot button issues you as a maintainer actually pay attention. And that is one thing that I think email presents something as just a simple message layout, and that is something that perhaps newer tools may have an advantage of into thinking about showing what's available and make things out.
So one thing I think they're twofold, right? One is keeping up with your email and reviews and figuring out that's a challenge, and the other thing is also one of the things that would be helpful is the tool to figure out the effort you and Sasha are doing in figuring out which fixes. And I think that's a bigger overhead for a lot of the maintainers as well, which fixes should go into stable, which should be tagged. And I think that would be immensely helpful. That would reduce some of the overhead maintainers have in tagging.
Okay, and I'm afraid I'm going to have to cut off the questions, but please help me thank the panel for today. Thank you.